Number 1, what percentage of students chose to take theater as their fine arts credit? Review. Okay, so first thing, make sure you got your total. So we would add up 560 plus 120 plus 40 plus 80. And what did you guys get when you added all that up?
800.
800. So anytime it says what percentage, remember you're making a proportion out of that. Okay, so 800. So I'm going to say out of 800, how many kids took theater?
9,000.
So there's 800 total. How many kids took theater? What's it say in the circle graph? 120. If it says what percentage, that means out of 100, because 100 would be 1% So that's what we're looking for. Okay, and how did we figure that out? You can scale up or scale down or cross, multiply, and divide. It's 120 divided by 8. 15%. Okay, on number 2, how many more, that means we're going to subtract. Number 2, how many more students are in all the other classes combined than in art? Okay, so all the other classes combined, aside from art, would be 120 plus 560 plus 40, right? And that's 720. So all the other classes combined is 720 minus 80 that were in art. And we get, what do we get, Jesse?
B. Oh, I got it wrong.
Uh-oh.
It was 15%.
Age.
I was doing like art minus.
Number 3, which statement is not supported by the graph? I'm going to say on your test, what I would do first on this question, because there's a question just like it, I would take the total you got, and we're going to use that. So 3 times as many students take theater than choir. So I don't know if it's going to help us on these answer choices, but on your test, I would take that number and divide it by probably 4, I think, on your test, because it asks about 25%, 50%. So you would divide it by 4. On this particular question, I don't think it's going to help us. But A, 3 times as many students take theater than choir. So theater than choir. If I multiply choir's number, which is 40, times 3 times as many, what do I get? 40 times 3. 120. So is that true? 3 times as many students take theater? 120 kids take theater, right? So that would actually work. But we're looking for one that does not work. So A is out. B, the same number of students take theater. So theater would be 120. As do the choir and art students combined. So 40 plus 80 would also be 120. So is that true? Okay, so that's supported by the graph. 75% of the students will take band.
That looks true. It looks true.
It looks true. Maybe we'll put a star next to that one. And D says twice as many students will take art as will take choir. So 80 kids take art, 40 kids take choir. Is that twice as many?
No.
80 is not twice as many as 40? Right. 80 is twice as many. Okay, on the bar graph, use the graph below to answer questions 4 through 6. This graph's kind of weird. The one on your test will be a little bit more clear. But I would go ahead and write the totals above each bar. So you already have those numbers. So like Jones has 90, Green, we're going to say 60. It looks like it's above that, but we're going to say 60. Taylor's 90, and Williams, we're going to say 120, even though it looks a little bit higher. So number 4 says about how many more students, that means we're going to subtract, does Mr. Williams have than Mrs. Green? So Williams had 120. Green has 60. So 120 minus 60 is 60. Number 5, about what percentage of students either have Mr. Jones or Mrs. Taylor? So we need to know, if we're looking for what percentage, that's x over 100. So we need to figure out the total amount of students there are. So 120 plus 90 is 180 plus 60. So we've got 360 kids total. And then how many kids are taking Taylor or Jones? How many kids combined is that? They each have 90.
180.
So 180 over 360. And you're setting up that proportion because it says what percentage. So what percent out of 100%? You can kind of eyeball that if you can kind of see 180 is half of 360. That would be 50. Or you can cross multiply and divide. You can do that also. Okay? Either way, you're going to get 50%. Number 6, if Mr. Jones, so look up at Mr. Jones, he's got 90 kids. If he teaches 3 math classes per day, what is closest to his average class size? What am I going to do?
Divide 90 by 3. Add and then divide.
No, he's got 90 kids total. And he's got 3 classes per day. So we're splitting those kids up into 3 different classes. So you're dividing it. If he's got 90 kids total, just like you guys, I have 3 classes of 7th graders. If I wanted to figure out the average class size, which they're not all the same, we would divide it up. So in this case, 90 kids altogether divided by 3 classes, 30. Okay, the plot below shows the ages of residents at Bear Creek Assisted Living. The black dots represent the residents in the East Wing. You're going to have one like this on your test, and I would, somewhere off to the side, I would write these things down so you don't have to keep counting them. You just have these numbers. West Wing are gray. Okay, so how many total residents is this dot plot representing? How many dots are there total? So we've got 20 total. How many are in the East Wing? How many black dots are there? Okay, so there's 10, so that means in the West Wing there's also 10. So how many more residents, so we're going to subtract, how many more residents under 84 years old, so from here down, how many more residents under 84 years old does the West Wing have than the East Wing? So West minus East. So just in that little fragment from 85 below,
It's 0.
84 below. Good, let's see, West Wing, we got 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, 2, 3, 4, 5, 6. Oh, 7.
It's 2, right? It's 1.
Should be 1, yeah. I missed a dot there at the beginning. Okay, what percent? Anytime it says what percent, you need to automatically see x over 100 and write that down on your paper. X over 100. What percent of residents are in their 80s? So let's look at just from 80 to here. 1, 2, 3, 4, 5, 6, 7. Good. So there's 7 out of how many total? 20. So what am I going to do here?
X over 100.
Good. X over 100. So cross multiply
700.
and divide. Or you could divide by 5. Just scale up. You can cross multiply and divide, or you can see 20 times 5 would be 100, so 7 times 5 would be 35. Okay, couple scatter plots. The box plot below shows Cassandra's grades in science this year. Use the plot to answer questions 9 through 10. What is the range in Cassandra's grades? What does range mean? What are we doing with that?
Subtract the biggest minus small.
Good. Big minus small. So her biggest grade, her highest grade was 97, minus her lowest grade, which was 58. What do we get? Should be 39. 97 minus 58 is 39. Which of the following statements is supported by the box plot? The median, so that's the middle, that middle dot. The median of Cassandra's science grades is an 82. Is that correct?
Yeah. Wait. Yes.
Right, the median. So that would be that middle line in your box. That's the median. So that's true. Just to check the other ones, Cassandra's mean grade in science is an 82.
No.
So no. When you get these box plots, that's going to be an answer choice. We can't figure out the mean from her box plot. Does that make sense? We can see her lowest grade, her highest, her upper median, lower, and her actual median, but we can't tell what her average mean of all of her test grades are. Does that make sense? Those medians. So that's never going to be the right answer. Cassandra's average. Average is the same thing as mean. Hold on. Mean and average are the same thing. So if you can't find her mean from a box plot, you can't find the average because it's the same. And then Cassandra needs to study more in science. No, she's fine. We can't prove that from the box plot. Plus, she got a 97 on something, so she did pretty good.